Alright, here's two questions where you were asked to rationalize the denominator. This first one is just one term, and so it's cube root of 2 over 5. I could write that as cube root of 2 over the cube root of 5. Now, when they say rationalize the denominator, what they're looking for is to get rid of the denominator on the bottom. So the only way I can do that is if I multiply top and bottom by something so that it gives me a perfect cube root on the bottom. For example, like say I had something over the square root of 2. If I can multiply both the top and the bottom by the square root of 2, then what I get on the bottom is root 2 times root 2 is root 4, and the square root of 4 is 2. So it comes out even. And that's what I want to do with this one. So I want to multiply by something. This is a cube root, so I'm going to have to multiply by the cube root of something on both top and the bottom, but I just have to figure out what that something is going to be. If it's a square root, like this one, all I need are 2 2's, and that's going to give me a number that I can take the square root of. If it's a cubed, I'd need 3 of the same thing, so I need 3 5's altogether total. So if I already have 1, so if I multiply the bottom by 2 5's, then what I get on the bottom, I'll do it down here, is the cube root of 5 times 5 times 5, which is the cube root of 125, and if you take the cube root of 125, you get 5. Another way to look at it is the cube root, there's 3 5's inside, I can cancel those and bring 1 5 out, and there'd be nothing left under the cube root. So all I'd have is a 5. But if I multiply the bottom by that, then I also have to multiply the top by that. So in this one, the cube root of 125 is going to be just 5, and on the top, I'd have the cube root of 5 times 5 is 25 times 2 is 50. And I'd be done. Okay, there's that one. Now this question 83 a little bit different because this one, they say again to rationalize the denominator, but here there's two terms. There's a term there and a term there. So to get rid of the denominator in this case, I can't just do what I did over here. If it's a binomial term, I need to multiply top and bottom by the conjugate of what I'm trying to get rid of. So if I'm trying to get rid of 3 minus root 5, then I'm going to multiply it by 3 plus root 5. That's the conjugate when you change that middle term. If I multiply the bottom by that, I have to multiply the top by that too. Okay, so these are binomials, all of them, and I need to FOIL those to get rid of, and hopefully get rid of the radical on the bottom. So let's FOIL the top first. 9 times 3 is 27. 9 times root 5 would be a positive 9 root 5. Minus root 5 times 3 would be a minus 3 root 5. And then minus root 5 times a plus root 5 would be a minus square root of 25. Oh, which I could figure out too. On the bottom, 3 times 3 is 9. 3 times root 5 is a positive 3 root 5. Minus root 5 times 3 is a minus 3 root 5. And minus root 5 times minus root 5 is another minus root 25. So on the top, I have 27. These two are the same root 5, so I can add or subtract them. 9 take away 3 would be a plus 6 root 5. And minus the square root of 5 is just 5. On the bottom, I have 9. Then these two, one's minus, one's plus, they cancel out. Minus the square root of 25 is 5. So on the top, 27 take away 5 would be 22, plus 6 root 5, all over 9 minus 5 is 4. At that point, I'm feeling pretty good, but I can take it just a step further, because on the top, I could factor out a 2, leaving me with 11 plus 3 root 5 over 4, and then 2 will go into 4 twice, and 2 will go into this once. So I'd wind up with, in the end, 11 plus 3 root 5 all over 2. Okay, hopefully that helps you with those two rationalizing the denominator questions.